This video is on adding and subtracting rational expressions. Adding and subtracting rational expressions is very similar to adding and subtracting fractions. You must have a common denominator. Let's take a look at several examples here. So my first example is 2m plus 4 over m squared n plus m minus 5 over 2m n squared. So let's start by figuring out what my common denominator should be. So my least common denominator is going to be the greatest factor, the greatest number of times that each of those factors appears. So I'm noticing I have a 2, I have m, and I have n. So I need to have a 2 in my common denominator. My first denominator has an m squared, my second denominator has an m. I have to take the greatest number of times that m appears, so that's going to be an m squared. And then for my n's, I have an n to the 1 and an n to the 2. I need to take the greatest number of times it appears, so I'm going to need an n squared. So that's going to be my common denominator. So let's rewrite each of those fractions with that common denominator. So 2m squared n squared plus 2m squared n squared. Now, in order to turn my first denominator into my common denominator, I need to multiply it by a 2 and an n. So I need to multiply top and bottom by 2n. Oops. So 2n times m squared n will give me my common denominator. And then for my second denominator, I think I just have to multiply by an m. Now, let's go ahead and distribute. So that's going to give me 4mn plus 8n. And I'm going to go ahead and add my numerators here, plus m squared minus 5m all over my common denominator of 2m squared n squared. And I'm noticing that I don't have any like terms to combine in the numerator, so even though it's a little funny looking, that's my answer. Let's take a look at our second example here. 14y over 9 minus y plus 2y over y minus 9. Did I say y minus 9 minus y? So the denominators are not the same, but they're very similar. So recall what we did in a previous lesson where I rewrote something that had the constant first followed by the variable and then factored out a negative 1. And when I do that, I get that this denominator is equal to negative 1 times y minus 9. And I'm very close to a common denominator, and in fact I can take this negative 1, and since it's in the denominator, I can put it in the numerator. Now I actually have a common denominator, negative 14y plus 2y all over y minus 9, or negative 12y over y minus 9. So that one looked a little tricky, but once I rewrote my denominator 9 minus y, it actually made a little more sense. And let's take a look at our last example here. I have 7 over 4x plus 8 minus x over x plus 2. So the first thing I think I'd like to do is to factor this denominator. Anytime I can factor something, I want to do that to see what's going on there. So 4x plus 8 factors into 4 times the quantity x plus 2, which is actually really great because that already contains part of my second denominator. So my common denominator is going to be 4 times x plus 2, which means I don't need to do anything to my first rational expression. All I have to do is multiply my second one by 4. So that's going to give me 7 over 4 times x plus 2 minus 4x over 4 times x plus 2. And here's a common mistake I've seen people make before is they'll look at this second rational expression and they'll say, oh, I can cancel a 4 on the top and a 4 on the bottom. Well, don't do that because we just multiplied it by 4 so that we would get a common denominator. Even though you feel like you want to cancel that, don't. So now I can just combine my terms across the top and write it with my common denominator. You can leave it factored, or you can go ahead and write it as 4x plus 8. So there is my answer. So in this video, we took a look at adding and subtracting rational expressions. Very similar to adding and subtracting fractions, need to make sure you have a common denominator and rewrite each rational expression with that common denominator, combine like terms across the numerator, and simplify if you have to.